A student does an experiment to estimate the density of an irregularly shaped stone. Which items of equipment are needed? Okay, like in order to measure the density, you are actually in need of volume. For density, we are in need of mass and volume. So for mass, we are in need of some sort of, you can say, oh, okay, one more thing, which is irregularly shaped. If it is an irregularly shaped, then hopefully we are looking for measuring cylinder. So we can we can use measuring cylinder. So measuring cylinder is required because of irregular shape, and in order to measure, we need a balance machine. So let's see. D. Only a measuring cylinder containing water. Wrong. Okay, that will measure that will measure the volume of the irregularly shaped uh, thing stone. Sorry, but how would you measure the mass? A ruler and a measuring cylinder. Okay, measuring cylinder will measure the volume, but the ruler cannot measure the irregularly shaped stone's volume. A balance and a ruler. Okay, a balancing machine and again a ruler cannot measure, so that's wrong. So it looks that a balance and a measuring cylinder containing water. A balance machine for mass and measuring cylinder for volume. So that's the correct option. Now number 32, a mass of 10 kg falls freely in a gravitational field close to moon's surface, has an acceleration of 1.6 meter per second square. Okay, so gravitational, okay, mass is given. This is mass. And acceleration is also given. This is gravitational field strength or acceleration. What is the gravitational field strength on the moon? Okay, gravitational field strength is already given, which is 1.6 meter per second square. So like sometimes g, like if suppose 1.6 meter per second square, it is written like this, it would be gravitational acceleration. But if its unit is 1.6 Newton per kg, then it would be gravitational field strength. So this is the value for moon. If the same G would be for Earth, if we just then G would be considered as, okay, 1 second. G would be 10 meter per second square for gravitational acceleration on Earth, and similarly G would be 10 newtons per kg, it would be gravitational field strength. The value, the gravitational acceleration and gravitational field strength, both are similar things. But when we would consider it as an acceleration, then its unit would be meter per second square. But when we would consider it as a gravitational field strength, the unit would change. So you can see the 1.6 meter per second square is gravitational acceleration, and 1.6 newtons per kg would be gravitational field strength. So this is our answer. Next is number 33. The inertia of a body is its resistance to change in motion. Which property is the measure of body's inertia? We are already talking about the mass. Mass is actually A property of an object which gives inertia. Which property? Mass is the property which is actually measure of body's inertia. So that's the answer. Rest of the things are useless, like the density, height, like these things. These are not only mass is linked with the inertia. Number 34. An object of mass 100 grams, this is the mass of an object, is immersed in a water as shown in figure. Now you can see, let's see, when there is no mass, its volume is 50. When this stone or metal or whatever is immersed in it, now its volume is 90. You can see its volume is 90. Previously its volume was 50, now its volume is 90. So the difference in volume, so old volume, new volume is 90 minus old volume, which is 50. So the difference in volume is of 40 centimeter cubes. Now we already know the mass. Mass is 100. And what about the density? Density is mass over volume. So mass is 100 and volume is 40. So density is 2.5. Okay. Next is three objects are cut from the same sheet of steel. When material is same, it means its density would be same. So it means all will have similar type of density. They are different in shapes, but all have the same mass. So their masses are same, their densities are same. It means their volume is also same. Okay. Which object has the greatest density? Like all of them are part of similar type of material. Three object has. Now let's see. Volume is actually we know that density is mass over volume. Now it says different shape. They have different shapes, but all of them have same mass. So it means volume is equal to mass over density. So all of them will have same volume. Okay. Actually, like we have now two hints. The material is same, mass is same, so their density is same, their volume is same. So shape makes no difference right now. So all of them will have. Okay. Number 36. At a point on the Earth's surface, at a point on Earth's surface, the gravitational field strength is 9.8. Okay, it's sometimes it is normally it is the original value is 9.81. We consider it as 10 for our simple calculation. Which pair of the values of mass and weight are correct to an object placed on its on this point? Gravitational field strength is 9.8. So we know that it's W is mg okay, now this is what we have. So gravitational field strength is 9.8. It means its weight is 98 and mass is 10. So that's why 98 divided by 10 is 9.8. So mass is 10 and weight is 98. 98 divided by 10 is 9.8.